We're delighted to have Mario and Justin, both members of the EV group at Swinburne University. They've recently converted their petrol car into electric cars. So they're going to go through the project and discuss and also tell you exactly what the problem is, etc. Mario's going to start the first session. Mario and his son, Mario and Michael decided to take this on as a project back in 2010. It took them 2 years, and then of course they've converted their car, had it pass through Rego, and it's out there for you guys to look if you haven't had it.
Thank you. Good morning, all. As you can see by the slide, that's how it started. At home in the local car park, racing remote control cars. And the suggestion by me was that we upscale it. So in 2010, with my son, it was a father-son project, we decided to build an electric car. How difficult could it be? Yes. Well, some of the points in a bit of a summary for you and moments that we had. We started in October 2010 and we finished it in September 2012. The 100 weekends was actually 96, so we thought that was pretty good. Best tool in the garage, the drill press, only because it gives you accuracy when you're trying to drill particular parts of a lot of aluminium that we used in framing. Most enjoyable part, as I said, it was started out as a father-son project, and that really was what I took out of it. Most frustrating, obtaining roadworthy. It seems that every time you re-register a car, you must change your windscreen, irrespective of whether it's good or not. Anyhow, silly mistake, wiring the throttle the wrong way. Fortunately, the car was on stilts. We drew 580 amps. I know that because my son was telling me when he was sitting in the car that when we connected, it drew 580 amps instantaneously. So we couldn't work out why until we looked at the diagram, and I had wired the throttle in reverse. So from that, the 96 weekends we took time and what have you on everything that all the time that we took to do things. If we were to do it full time, it would be a 3-month job from start to finish. So we're just starting a book of quotes for EVs, and one that came up was, only at the end do you find out what doesn't work. Main considerations that I suppose if you're looking at building an electric vehicle from a donor car, or for that matter from scratch up, is obviously budget. We budgeted $20,000 for the build. It ended up costing us 28, so a little bit over, but as said in the beginning, it was a project that I took great joy out of. AC, DC. Which way do you want to go? AC is good because your regen facility and charging your batteries. DC was a bit cheaper. At the time that we started doing this project, AC wasn't that much more expensive, but the problem with budgets is if you allow something, then before you know it, you're going way over budget. So we stuck to DC. But if we were to do it again, I would definitely now go AC. Traction battery voltage, again, it'll depend on whether you want to go AC, DC. AC requires a lot less in terms of your platform. On what we had done on the vehicle, we based it at 144 volt. The same vehicle using an AC motor, we would have got away with it with 110, 120 volt package. Aircon, little notes on aircon, heater, power steering. That's really to do with if you do utilise a donor car, whatever the car has, you must make that also working in terms of getting the car registered and through the requirements of the Australian design rules and regulations. So if the car had air conditioning and you've taken it off, or it had power steering, for argument's sake, like we had, off the internal combustion engine, at the end of it you must also have the power steering working, but using obviously your battery pack. So an electric pump is required. Engage a VAS engineer. This will save you a lot of time and a lot of money, and show the VAS engineer your intention right from the word go. Because if you think that you've got something that will work when you take it to the engineer, first up, he'll either tell you yes or no. If you then do it and you take it to an engineer, he is likely, or may, if you've done it incorrectly, you have to take everything apart. So you've spent a lot of money and a lot of time. So engage a VATS engineer. EV to B, the donor car. We selected a Ford Capri only because I just wanted something aesthetically to look a little bit nicer rather than just a square box with some batteries in it. Although the square box is probably easier to work with because batteries are square. And the EV presented, the Capri presented some challenges, which I'll show you in some slides as we go through. The motor, internal combustion engine, that was removed, although this slide is a bit different because my original slide, this is a double overhead cam. The motor that was removed hasn't got a double overhead cam, but that's the motor that came out of the car. Bathroom scales, very handy. And the reason for the bathroom scales was that keep a note of all the weight that you take off. Becomes important later in your calculation on where you're going to put your weight distribution. Well, any vehicle for that matter, your weight at front over your front axle needs to be higher than your rear brake steering. So make note, and we did. We kept a note. We actually calculated in grams because a lot of the stuff wasn't kilos, but as you go along in grams, they also make kilos. So weighing. Cardboard mock-ups. We made up cardboard mock-ups to visualize where the motor, perhaps the controller, perhaps some batteries would go. It makes it a lot easier for you to work on the area that you've allocated. So cardboard mock-ups are good. Adapter plate. We didn't do the adapter plate. It went to an engineering place. PC Engineering did ours. So from a template, the adapter plate, as you can see there, was made. The centre is the original clutch. We actually cut the clutch down and maintain the torsion springs so that when you're in gear and you take off, it takes up that slack so you don't hear that clunk. So we maintain that. The coupler is solid and it goes directly into the drive shaft of the original gearbox. The motor was a Kostov 9-inch series wound DC, and that's the photo there showing it going into the engine bay. It's my son, extra pair of hands, always helps. Position of the motor onto the gearbox. You can see on the top right hand side the power steering pump, which is a 24 volt electric motor. The reason for the 24 volt, it just makes it go slower, so that the liquid going through the hoses gives you a more accurate sense in power steering. Another photo of the motor being positioned, but more importantly, when you've put the motor in, because the end bracket on the left-hand side was not done, supporting just to support that end of the motor. The motor total weight of this motor was 60 kilos. So at this point, not all the bolts were bolted onto the adapter plate and the bell housing because we had to make adjustments. So a good idea to support the motor.
How heavy was the motor?
60. The original motor, 120 kilos. Halved it, yeah. But there's a lot of other parts that went in that made up for it. As I said, the Capri presented challenges on where were you going to put the high voltage parts, and although we'd made up cardboard mock-ups, we found that by using a string line, and that string line there, nothing can come up above it because most of the high voltage components were going to be below that string line. If you had it above, the bonnet wouldn't close, and not a good idea with high voltage stuff. So the string line came in very handy when you were looking at how to position it. And we used angle line to make the frame. Just this photo shows the motor end now with the end bracket. And the end bracket was quite unusual because the original engine mount, what we found is if we actually reversed it, it was dead top center and absolutely in line with the motor. The only thing we had to do, because it then took it off the chassis So there was no weight. We had to make a bracket to sustain the weight and bring it back to the chassis. But we just reversed the original engine mount, just turned it upside down, and it was a perfect fit. Fluke. Vacuum pump, power steering, engine starting to come together. The high voltage tubes you see at the back was not high voltage. They're just well, I suppose they would be high voltage because it goes to the heater. Yeah, so they are high voltage wires. Goes to the heater, which was being made to ceramic, and I'll talk about that in a minute, a few other slides. But this talks about the vacuum pump, and there's a water bottle, aluminium water bottle, that was the reservoir that we used as a reservoir for the vacuum pump, because the original pump worked off your internal combustion engine. As you moved along, it created a vacuum for your brake booster. Well, that's gone, so the vacuum pump does that job, and the bottle becomes a reservoir. That particular pump I haven't used that. We took that off because we weren't happy with it. So the new pump there doesn't actually require a reservoir, but because we already had it, we've maintained it. So it's got a reservoir plus doesn't really need it, but it's there. The throttle, we've positioned that underneath where the controller will go. It was just easier for the cable, where the cable came out from the car, the original cable. It's just easier to put it there, and we were able to put the controller over the top, which is hinged. All this time in making the frame and putting the motor in and what have you, we really didn't know where the motor worked. So we didn't do a bench test on a DC motor on a bench because I couldn't put any load to it. So we had to wait till it went in, so the load was the gearbox. So we just used a 12-volt battery, connected it up, and it turned. So we were happy, so it all worked. The heater, again, needing to comply with requirements of the National Code of Practice. The heater was originally a water-cooled heater, so we had to use this for the misting purposes. We used a ceramic heater. Went to Bunnings, bought an $8 ceramic heater, immediately voided the warranty because we ripped it apart and took out the two ceramic heaters of 15. It was 1,500 watts in total. So they were positioned in the original measurements of where the water heater went, placed back into the housing, and the board there shows you we tested it, and all worked fine.
What was the voltage there?
And when we tested it on Reese's car with 120 volts. Yeah, I'm using 144, so there was more to see whether it didn't blow up. So at this stage, we've got the control, the circuit breaker that's in, and the DC-DC converter, which takes over from what an alternator would do for your vehicle. So there's 144 volts coming into the back of the DC converter, and 13.75 volts, which is adjustable to the 12-volt battery systems. Should mention that there's two systems. There's the traction battery system, which is a 144-volt platform, and there's the original 12-volt system that runs your lights, your horns, indicators. That's all there. So the DC-DC converter, as I said, takes over from what the alternator would do in a normal vehicle. And it's adjustable. As I said, the controller just shows that it actually lifts, and it shows you where the throttle, which is under the controller. Again, for compact. Yes.
Can I just make a suggestion that when you're indicating, if you indicate on this one, because it's when you talk about components, it's hard to identify.
Oh.
Yeah. When I know when you're talking, yeah. You're pointing at the screen.
Oh.
You're pointing at that screen.
You're absolutely right. Yeah, because you can't see my finger, can you? I could be doing anything. Correct. As you can see there, the controller is hinged where the throttle, to access the throttle, should you need to, and sometimes there are times when you may have to adjust the throttle. It works on a spring mechanism. The Hall effect, in fact, I had to replace one because one was faulty. so we replaced the throttle, and that's where it sits or lives. High voltage components were all placed in one area, just for the sake of keeping high voltage components in one area, rather than have high voltage stuff in all different parts of the vehicle. Is not really a good idea. So we've kept it all in one area. It also makes it easier to lock or be able to have the high voltage components being locked and or under lock as a requirement. And there it is. The central panel is all the high voltage, which can be locked, and there's a key, a special key that you need to unlock it, which is a door handle that we used on an original door. Again, remember, this is in a garage, and it's a bit of a project, but we're complying with all the regulations that's required. When we did the center part, as you can see, we looked at the car, the end result, and we thought, for 2 extra more panels, it looked much nicer. So we did. We added 2 extra panels. They're 12 volt. Underneath those are 12 volt. One's a battery, and one's the vacuum pump. So there's no requirement to have that lock, but the panels are there. We added some LED lights underneath the main leaders. You can probably see they're on. And the only reason for that is that if for whatever reason, sometime at night, rather than a torch, there's several LED lights positioned on components over the motor, so it just lights up so you can see what's happening, whether something's come loose or whatever. So they're there. They have an onboard charger which is positioned in the boot. We've maintained all the boot space. We still have the spare wheel there. The charger sits over the wheel arch, and the battery management system sits on top of that. You try and keep your battery management system, as recommended, as close as possible to your batteries, which are in the rear, where the rear seats used to be. And the Capri, the rear seats, there really wasn't a lot of room in terms of seats, so that's where all the batteries have gone. 2 tiers, 35 lithium iron phosphate, 100 amp, 35 on the bottom, 10 on top. The 10 on top actually lever. And the only reason for that is on each battery there's a module. When you're charging, it'll give you an indication, and then it'll also give you another indication as it passes on that charge when it's reached maximum charge. So if you wanted to know whether any of the batteries may be faulty, you had to have a way of being able to view it without sort of checking each one with a multimeter. So they actually lift, and you can see that when it's charging. At the rear of the battery pack, which also lifts, is the main contactor, as you can see, and there's the auto pre-charger. It pre-charges before it makes contact because of the high voltage that's going through it. And that's well at the back and protected and covered, as are all the terminals. You can note all the plastic in front of the main connectors. It's all protected, so you can't accidentally touch it. Well, you'd have to touch both positive and negative if you're going to do any damage anyway. Just touching one's not going to hurt you. The obligatory cap, filler cap has now become a 3-pin household 10 amp plug. The actual plug is rated to 15 amps, and we did that because we have facility at our place for a dedicated 15 amp line. So one day we might increase the charger on board to be able to take the capacity. Specifications and parts used in summary is there. Our platform is 144 volts DC. The budget, as I mentioned, was 20,000. We ended up spending 27,600. Range 84 kilometres. Wasn't bad. We calculated 85, and the reason I know it was 84 because we stopped 1 kilometre from home. So yeah, tow truck later. So we now base it on 70. So based on 70, you're looking at 205 watt-hours per kilometre. During the week, we charge, as it says, charge it 3 times, roughly per week, and utilising a timer. We increased our weight by 88 kilos from the original curb weight. The good thing was that we've actually improved the handling of the car because Now we have 600 kilos on front axle and 530 over the rear axle, so almost a 50-50 weight distribution when you're driving. And it's a different feel driving the car now as electric compared to when we drove it into the garage a couple of years ago when it was a petrol. It just handles a lot different, completely a lot different.
Does that redistribution of the weight impact your re-registering of the vehicle?
No, not at all. In fact, it enhanced it. It's actually better than original because of that close to 50-50 weight distribution. And you notice that when you're certainly driving around corners, you don't get that lean or roll. It just goes around the corner. So we were quite pleased with that. Again, that really came a lot from measuring everything we took out. And then when we were putting components in, where we would put the components to compensate for that reduction or removing of weight, and where we're going to put the weight back in. We kept a weight matrix, so everything that we did. Transmission, it's a 5-speed manual. The noisiest thing in the car is the gearbox. I think some bearings probably needed to be doing, but again, going back, it was a project. I didn't want to spend too much money on it, but we used 3 gears, second, third, and reverse. First gear is only used on very steep hills because of the lower ratio. Otherwise, from second gear, we up to 60.
Get a gearbox to work on an electric car. Is that because you use DC?
No, it's just the drive shaft goes directly into the gearbox. So when your electric motor is turning, it's turning the shaft, and when you put it in gear, you're in gear.
So usually the drive shaft goes straight to the wheels.
You can, yeah. But maximum, this motor maximum RPM is 5,000. It's rated at 5,200 RPM. Not that you would ever get to 5,200 RPM, but the gearbox was there was no, and actually using the gearbox made obviously a lot simpler, because otherwise, how are you gonna drive the vehicle? Yeah, especially on a front wheel drive.
Its torque is the same as before.
I'm not sure whether it's the same before. I've got no ways of measuring the torque.
Which is why you can start off in second.
Yeah, probably more, because to get in second gear to 60 is very quick.
Is it faster than before?
Oh, I'd say so, absolutely. It's continuous acceleration.
So Mario, there's no clutch changing this?
No.
So that the actual clutch is just a...
The clutch is now part of the coupling, so I actually took the clutch pedal out. So it's just a brake and an accelerator with a manual.
So just a change?
Yeah, it just changes as you go along, and you know that when you're changing down with the synchros and the gearbox, we've worked out on this car at 40 kilometres an hour, you can just put it back into second and there's no crunch. So pretty easy. As I said, second gear we're up to 60, third gear it's 100 plus, so and reverse gear. And to phase 1, phase 2 extension of range, we'll work on that. So thank you. Yeah.
Can I just ask you, you mentioned air conditioning earlier in the piece there. Did you do anything about the aircon?
It didn't have air conditioning.
Didn't have it.
Yeah. So if it doesn't have air conditioning or power steering, you don't have to comply.
So would that mean that you'd probably be better with an older car that didn't?
Oh, absolutely. The old car we have to worry about is you don't need the old cars have brake boosters. So power steering.
That's a 1600 out nothing.
So I mean, it's not that difficult. It's just it's an electric motor and controller, and that's it. And the power source.
All right, change the tyres.
Huh?
All right, I'll make a start on my talk as well. Everyone can grab your seats. Now I need to apologise that I actually don't have my PowerPoint presentation because I mucked up file names and I ended up I copied the poster to this expo rather than my presentation, which isn't very helpful. but I can remember most of what I was going to go through, and I've just put up on the screen the page off EV Album, which is probably one of the best resources on the web in terms of getting info about converted electric cars. So at least you've got something to look at and go through the specs. But I will. What I wanted to do is just go through at a high level some of the lessons, I guess, from having done a conversion, and some things I do differently, and a few recommendations, because it is quite a big undertaking. So the car I converted was the Mitsubishi Lancer Coupe. Basically very similar conversion in approach and design to Mario's that you just saw. The key differences being that I've got a split battery pack, so I've got almost half under the bonnet, half in the boot. And the benefit there was retaining sort of all 4 seats, so I can use the rear seats as well, because I wanted that practicality. The downside is obviously you're splitting mass to the front and rear, so it's not as centralised in terms of handling. But these are the compromises you kind of have to make. I also went for a water heater rather than Mario's ceramic heater, so I just plugged directly into the existing heating system, and I didn't have power steering, whereas Mario does, so I just pump up my front tyres with extra hard. So I guess one question these days is, why would you do a conversion rather than buy an electric car now that they're on the market? Because when I started and Mario started, you couldn't go out and buy an electric car, so conversion was kind of the only way. I still think that there's some good reasons why you might want to do a conversion. If you're not counting labour, if you're doing it as a bit of a project or a hobby, it still is cheaper than buying a production electric car that's new. You can choose the car that you want, which is, I think, a really big plus. If you want the convertible, or you want a little sports car or a vintage car, you can do that. You're not restricted to a Leaf, an IMEV, or a Volt. You effectively are recycling an old car, which, giving it a new lease on life, keeping it out of the scrap heap, which is certainly a good thing environmentally, and I think is satisfying as well. Putting a brand new drive system into an older car can keep it on the road for another 15 years or something. And it's a fun project as well, and by fun I mean it oscillates between tearing your hair out and actually being fun, but overall it is a very rewarding project. So a little bit on the overall process. Mario mentioned about the VAS engineer before. So that stands for the Victorian Automotive Signatory Scheme. They are accredited by VicRoads as automotive engineers that can sign off on major conversions and modifications, and then you take your signature from them to VicRoads, and they'll process your conversion for you. So really, they should be your best friend through this process, and engaging a VAS engineer up front is recommended. So ideally, you would find your VAS engineer, or talk to a few of them perhaps. Consider donor cars, and once you've selected it, go back and talk to your VAS engineer that they're happy with that car as a base in terms of what you want to do with it. Work out your battery layout. Are you going to cut a hole out of the back seat and weld the box in? Are you going to mount boxes like I did and bolt them into the boot and the bonnet? And then talk to your VAS engineer again about that, because that's about weight distribution. It's about what you're doing to the chassis in terms of cutting, drilling, bolting. And then you can move on to other things like your motor design and pretty much then get into the build, and then you would have another check towards the end with your engineer again, and then they might want a few things tidied up for their final sign-off, and then you go to VicRoads. That's the ideal way. I did a less than ideal way, because I sort of launched in and didn't really think of these big picture things. I went and chose my donor car and bought it. I went and bought my engine or my motor and installed that. Then I got around to thinking about batteries, started working on that, and then thought, okay, I probably better go and talk to some VAS engineers at that point. Luckily, I found one that was happy to deal with my car and that was comfortable with the approach I'd taken, but it certainly was a bit higher risk in that respect. So one of the major constraints with the VAS engineers that I've discovered is any cars post 1996 are subject to frontal crash requirements in the Australian design rules. So the ADRs were changed at that point, that there were G-force reductions in frontal impacts as part of the design standards, and some engineers, some BAS engineers, are not comfortable with you changing parts of the car, especially under the bonnet, that might impact that frontal crash performance, and they won't want to sign off on it or work on it. So I had one BAS engineer told me that, yeah, he could do it. The only way he could do it properly is if I built one and crashed it, tested it, and then, didn't want to work as if. And then he started talking about, oh, we could do a whole lot of advanced software modeling and blah, 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 and it all got very complicated. So different engineers have different approaches, and some are very pragmatic. The engineer I used said, all right, as long as you don't put big solid lump of batteries inside the crumple zone, so about half of the bonnet is taken up by crumple zone at the front, and the rear half, that's where the original engine sat, it doesn't really crumple that much. So he said if you keep the batteries behind that, he's happy with it. So that got me around the fact that my car was 97. It still has to comply with those ADRs. The next level of difficulty is if you have airbags, because that also knocks out another layer of engineers that don't want to touch cars, where you're modifying things in the front of the car that have airbags, because the airbags respond to a certain way the car crashes and deceleration forces. So if you're changing things, that could impact the airbags. There are some engineers that will do cars with airbags, but they probably have a higher level of things that they'll want you to prove and check off, and there'll be more cost in it for them as well. And then probably the next level of difficulty again is if you go with a brand new car that runs a CAN bus type control system rather than good old just 12-volt wires going to each accessory. So then you can get into issues of programming all your components to work with CAN bus. So I think that the balance there is between an older car that's a lot easier to convert and get compliance versus a newer car in better condition that you might be happy with for the long term. So you've got to find that balance, and definitely get a car that's in good condition, or you can bring it up to good condition, because you're going to be spending the best part of 20 grand on the conversion. So, buying a $2,000 car with a bit of rust and, knackered in various areas is just not going to save you money in the long term when you're putting that much investment into it. Also on the donor car, it's important to consider the balance between a large car that can carry more batteries and a small car that's lighter, because they're the two kind of main inputs to the range and performance you're going to get out. So you want something ideally that's reasonably light, but that has a good headroom in its gross vehicle mass, that it can carry sufficient batteries and has physical space for the batteries. And probably the ideal solution is really like a smaller ute that is light, and you can just fill the tray. It's got a nice big gross vehicle mass. Fill the tray up with batteries. Not everyone wants a converted ute though, so you've got to find something where you do strike that balance. And for me, I wanted 4 seats that I could use it to carry friends and family around in, that still had enough range for daily activities. So I'm getting about 60 easily up to 75 k's range with just batteries under the boot and the bonnet. So that was kind of the balance that I struck. And I also recommend keeping your car registered throughout the conversion process if you can, even though you're paying for a couple of years registration where it's probably off the road. Saves a lot of hassle, and then you're not re-registering the car, you're just submitting a modification compliance, so you don't have to go through the whole roadworthy thing again. Which, as Mario said, means you're going to have to spend money on windscreens and other things which you may not need to. One of the main decisions you have through the design process, I guess, is the AC or DC drive system. And as Mario said, I would also try and go AC if I was to do this again. You get a better efficiency. You get regenerative braking with AC. they just weren't as available off the shelf when I started this project, and even now the power output, you know, dollar for dollar, you'll get more power output from a DC system than an AC system. So, but I guess I would try and find harder, or try and work harder to find an AC system that gave me the power that I wanted. The other interesting, I guess, discovery I made was that you need to look at designing the system in its entirety, the drive system, from the batteries and their performance, the controller and its performance, and the motor and its performance, and try and match them all. Because I guess what I've ended up with is a controller and a motor that can both handle very high output, whereas my batteries can only provide about half that power. So the best I'm getting out of my batteries is about 400 amps, whereas the controller and motor could probably handle up to about 1,000 comfortably. So it just means that I guess I'm not getting the full benefit of that motor and controller. And it's hard to know what to do there, though. The only other thing I could do is add more batteries to boost up the battery performance, or go to a more expensive, higher output chemistry. But it sort of meant that my initial calculations on the performance of the car didn't quite get there because of the batteries. That said, it's still perfectly fine. It'll do 100 k's an hour quite quickly. It's probably faster accelerating at lower speeds than it was originally. It's just not quite the tyre shredding monster I thought it may have been if I'd had 140 kilowatts going through the front wheels. It's probably more like you know, the 80 kilowatts. So anyway, that's fine. So overall budget, also similar to Mario's, probably about 20k by the time you add up all the components. I didn't try and cost my labour, but you know, there's probably 10 or 15 grand's worth of labour you end up putting in, but you don't count that because it's good fun as a hobby. And I think these days, because I started buying components quite a while ago when the dollar wasn't as good, you could probably get a decent conversion in for about 15 grand's worth of main components. It's but there's always the temptation of up-speccing here and there, and it can build pretty quickly. And time-wise, it was probably about took about a year of thinking about it, about a year of planning and buying components, 2 years of actual building, and this is just weekends and dabbling, kind of, you know, when I had time. 2 years to get to test drive point, where I did my midnight run around the block with no bonnet and flashing lights and everything. That was very fun. And then another year to bring that up to spec, finish everything off to get it complianced, and then the last year has just been sort of improvements and a few little alterations. I've got a big list on the to-do list going forward as well. So that's kind of the quick overview, high-level things, and my car is parked outside, so feel free to come and ask the more detailed questions then. Apologies again about the PowerPoint presentation, but hopefully there's something interesting there for you as well. Thank you.
Any questions? Are you guys still married?
Yeah, we are.
How do you like the cost of the wife?
Well, I said this is an alternative to buying a new car, so you know, justified that way. It's an older chassis, but it's got brand new drivetrain, so it's pretty much new.
She's wrapped in the drivetrain.
Yeah, that's right. Yeah, totally. And the other important point was I managed to get it pretty much all finished before our daughter arrived, because now I don't have time for anything. So.
Your coupling between your motor and your gearbox,
yep.
Did you have to design that yourselves, or did you get an engineer to design it for you?
I got a machinist to kind of design that up for me. Yeah, CNC machines. That's the sort of the most specialised fabrication part of it, is the coupler, where you basically got the spline drive on one side from your clutch, and then just a locking pin sort of attachment onto the motor, and the adapter plate as well, aligning, because that has to be very highly accurate. Yeah, that's right. So definitely take that to try and find a machinist that's happy to do that. There's probably $1,000 worth of work in that part of it. But, yeah. Yep.
What would be the downside of bypassing the gearbox going to?
The downside with the DC drive systems, they have a much wider torque range than the internal combustion motor, but it's still not wide enough to really take you from zero, starting off up to 100 k's an hour. Some people have done it, but you have to oversize things so that it'll handle very high currents when you take off in a high gear, and you sort of limit it a bit at the top end speed as well. So just to stretch out your speed, and to mean that you can start off without drawing ridiculous currents, it's definitely good to have the gearbox still. So personally, I leave it in third gear around town, start off in third, and then on the freeway I change to fourth or fifth. So yeah, it depends on the ratio of your own gearbox. But the AC system, some of them will they can have a very wide torque range, and you can get away with a direct drive.
I'm actually considering a motorcycle conversion, and was thinking of bypassing the gearbox. Yeah, because it gives me extra battery storage.
Yeah, if you can, it's definitely good. It takes out complexity. You just got to make sure that the motor and controller is happy to work over the wider rev range.
Would that save much weight?
Probably not heaps in the motorbike, or a gearbox only.
Or a car?
I mean, yeah, car, the gearbox is a fair chunk. It'd be, I don't know, 50 kilograms, 40 or something.
So you can just take the you have.
Yeah. If you're using the right system where you don't need it, you can. Yeah. Yep.
Almost get halfway through a motorcycle.
Yep.
Done it all wrong because, as you say, it's better than playing horse and trees. But I'm now at the battery point, and even though I'm an electrician, I'm really having trouble deciding which. Did you buy the individual cells and the separate battery management system and build your own pack?
Yeah.
Around to suit that, or did you teach yourself? Or?
No, I mean they're off-the-shelf components in terms of buying the batteries and then the BMS. I wasn't doing my own circuitry design with BMS or anything. It was buying modules. Pretty much a job of mounting them, soldering everything up, and connecting it. So that was from a supplier, EV Power in Western Australia. And they import the batteries. He's designed his own BMS, and it's all designed to work together. So fairly straightforward, labour-intensive soldering. But yeah, for a motorbike as well, you might want to look at the smaller cylindrical batteries that have a bit higher power output, the headway type ones, and you can get BMSs that work for them too. Yeah.
Thank you.
All right. So all good for questions. Thank you.
All we need is the name of your best people.
Best people, Archie Robertson in Bayswater.
On Bayswater.
Yeah.
And does the same thing apply as far as motorcycles?
I think so. Yeah, I'm not 100% to be honest, but I assume it would. Yeah.
So,